All right, today we're going to be looking at rationalizing the denominator and a few different variations on what to do, so let's get into it. Okay, so this first example here, 8 plus 3 root 2 over 4 root 5, we want to rationalize the denominator. So basically we want to get rid of that root 5. Now, a lot of mistakes people make is they actually multiply by 4 root 5 over 4 root 5, when in reality you don't need that 4. Okay, so just take the root 5 over root 5, which is 1, so it doesn't really change what we're doing. Okay, now, once we've done this, all you're doing is, right, you're expanding this like you normally would when you multiply brackets. So 8 times root 5 is 8 root 5. 3 root 2 times root 5 is plus 3 root 10 over, so you got 4 root 5 times root 5. So root 5 times root 5 is just 5, so 5 times 4 is 20. And make sure it doesn't simplify, and in this case it doesn't, so you're done. All right, so next example, you've got root 2 plus 5 over root 3 minus 2. Now you'll notice in the denominator, now we have an operation with two surds. So what you need to do is, you need to multiply by what we call the conjugate, and that's just a fancy name of switching the sign in the middle. So if it's a negative, you make it a positive. If it's positive, you make it a negative. So here, we multiply by root 3 plus root 2 over root 3 plus root 2. And like before, now you're kind of just expanding brackets, binomial expansion. So 1, 2, 3, 4, like that. Okay, expanding this gives root 2 times root 3 is root 6, plus 5 times root 3 is 5 root 3, plus root 2 times root 2 is 2, plus 5 root 2, over. Okay, now, the denominator, when you do the conjugate thing, you're going to notice that you're always going to get a difference of two squares. So, basically, remember this, a plus b, a minus b, this expands to a squared minus b squared. So in the same way, you're going to have root 3 times root 3, which is 3, minus root 2 times root 2, which is just 2. Okay? Now, of course, you could just expand it a long ways, but here's just a quick trick. Simplifying that, like terms, so the numerator doesn't look like it has any, so root 6 plus 5 root 3 plus 2 plus 5 root 2, and you're done. All right, so this one a little bit more complicated. We've got an operation with two fractions and then two different, I guess, surds in the denominator. So what we're going to do is, in this circumstance, when these surds are different, and they're not a difference of two squares, I'm going to do them separately. So what I mean by that is, I'm going to rationalize them separately, and then I'm going to bring it back together. Let's do 5 over root 6 plus 2. So remember, times by the conjugate, so root 6 minus 2 over root 6 minus 2. Expand that out, so you'll get 5 root 6 minus 10 over, remember, difference of two squares, so you're going to get 6 minus 4. So 5 root 6 minus 10 over 2. Okay, now what about this one? So you've got 2 over 5 root 3. So remember, just times it by root 3. So you get 2 root 3 over 5 times root 3 times root 3, which is 5 times 3, 15. And that looks like it's as far as it goes. And what I'm going to do is I'm just going to bring these back together. So equals 5 root 6 minus 10 on 2 minus 2 root 3 on 15. So now I'll just focus on this. 2 and 15 gives me one denominator of 30. So I need to multiply the left-hand side by 15. So that's going to be 15 bracket 5 root 6 minus 10. And I need to times the top right-hand side by 2. So 2 times 2 is 4 root 3, like that. Okay? Expand the numerator out, so you'll get 15 times 5, I think is 75 root 6, minus 15 times 10 is 150, minus 4 root 3, over 30. I don't think there's any like terms, so you are done. Okay, so one more here. This one's a bit different. It says if x is root 3 plus 2, simplify x squared plus 1 on x squared. So what I'm going to do is first, I'm just going to substitute what x is into that expression. Okay, now, there's a bit of a trick here. What I'm going to do is I'm just going to leave this bit alone for now, and I'm going to rationalize this separately, and like before, bring it back together. So, all right, I've just written out this bit on the side with the denominator. Let's expand it out. So that's what the squared gives. Now I'm just going to expand it all in the denominator. So once you expand it out, just combine like terms. So that's 1 over 7 plus 4 root 3. And now I can do the rationalizing. So remember, multiplying by the conjugate. So in this case, we've got 7 plus 4 root 3. So we're going to times it by 7 minus 4 root 3. Okay, so now it's just about expanding it out. So 1 times 7 minus 4 root 3 is 7 minus 4 root 3. The denominator will be the difference of 2 squares. So 7 times 7 is 49 minus 4 times 4 is 16. Root 3 times root 3 is 3. So 16 times 3 is 48. So that will be 7 over 4 root 3 over 1. So that works out nicely. All right, so let's put this number back up into what we had originally. Okay, so I've just substituted it back in. Now you'll notice that the left-hand side, so root 3 plus 2 all squared, well, we've actually already expanded that out, haven't we? So if you look over here, that's root 3 plus 2 all squared, and it just expanded to this, which led us to this, 7 plus 4 root 3. So I'll just replace that. So 7 plus 4 root 3 plus 7 minus 4 root 3. 4 root 3 is going to cancel out, so all I'm left with is 14, and I'm done.